Back children, in this video we are going to solve questions on combinations and its theorems. Let's see these questions. Here it is given, if NC8 equal to NC2, find NC2. I told you in theorem that if we have number of elements same and the selections are done differently, and if they have equal to sign in between them, then we can calculate n by writing it as a plus b. So what is your a over here? 8. What is your b over here? 2. So your n is 10. Now the question is find NC2. That means n value we have calculated, it is 10. So you want to calculate NC2, which can be written as factorial 10 upon factorial 10 minus 2, which is factorial 8 into factorial 2. Now you have to expand this factorial, and you can expand it like this is factorial 10. I will be expanding it to the factorial 8. So it is 10 into 9 into factorial 8 whole upon factorial 8 into factorial 2 is just 2. 8 and 8 factorial 8 gone. 2 5s are. So this is 45. So the value of 10C2 is coming out to be 45. Now come to the next question, children. Here it is given 2NC3 is to NC3. So here you can write it as 2NC3. So I can write factorial 2n upon factorial 2n minus 3 into factorial 3. This is in ratio, so I can write it as whole upon factorial n upon factorial n minus 3 into factorial 3. This I have used NCR formula, which is equal to factorial n upon factorial n minus r into factorial r is equal to, this is 11 is to 1, that means 11 by 1. Now children, here you see which is greater, 2n is greater, so I will be expanding this. So I will be taking it as 2n, then it will be 2n minus 1. We always move towards backward. So subtract 1 from each term. So 2n minus 1, then again subtracting 1, it will become 2n minus 2. And then because in the denominator it is 2n minus 3, so I am stopping till here. This is factorial 3 and factorial 3, it's gone. Upon this is factorial 2n minus 3 in the denominator, and here it is factorial n. So I am writing it as factorial n equal to 11 by 1. Now children, if I take 2 common out of this, it will become n minus 1. So here I can write it as, I am doing it here. So it can be written as 2n into 2 I am taking out from here. It is 2n minus 1, again n minus 1, and this 2n minus 3, 2n minus 3 gone. Here it is factorial n. Now factorial n can be written as n into n minus 1 factorial. So this is like here, n and n again gone. I can write this as equal to 11 by 1. Now solving it further, I will get it as, here we have left this term n minus 3 factorial, which will go upwards. That means I will get factorial n minus 3 term over here. So what I can do over here, this is 2 into 2, 4. This is 2n minus 1, n minus 1. This is n minus 3 factorial. I can open it further. This will be n minus 1, n minus 2, and up till n minus 3 equal to 11. So this and this again gone, n minus 1 gone with n minus 1. I am left with 8n minus 4 equal to 11n minus 22. So I'll be getting it as 11n minus 22. So 11 when come this side, it will become minus 3n, and this will be plus 4, so it will be minus 18. Minus and minus gone, so n equal to 18 by 3, which is n equal to 6. Children, always remember your n will always be greater than the value of r. If you are writing NCR, then this r cannot be in negative term, and this r cannot exceed the value of n. Let's see the next question now. The question given to you is, how many chords can be drawn through 21 points on a circle? There are 21 points on the circle, and how many chords are possible? How many chords we can draw out of these 21 points? So you know that if we select any 2 points, then a chord can be drawn. That means the total number of chords that can be drawn is equal to 21C2. That means you have 21 objects and you are selecting any 2 points to draw the card. So the number of chords will be 21C2. You can expand it. It is factorial 21 upon factorial 21 minus 2, which is factorial 9 upon factorial 2. I can solve it further. This is 21 into 20 into factorial 19 whole upon factorial 2, which is just 2, and into factorial 19 is over here. So factorial 19 and 19 gone. 2 tens are 20. So this is 210. That means there are 210 chords when we have 21 points in it. Let's see this question, children. Determine the number of 5 card combinations. That means you need to select 5 cards out of a deck of 52 cards. If there is exactly one ace in each combination, you want to select 5 cards, but it has been said in the question that one card should be an ace card. It should be an ace card, and other 4 could be any of the card. So you need to do 5 selections out of 52. That means out of 52. But in this out of 52, you are selecting this one ace card from how many cards? You know that there are 4 ace cards in the deck of 52 cards. So out of 4 ace cards, you want to select one, and how many are left now? 4 cards are ace card, and out of 4 I will be selecting one. Now I am left with just 48 cards, and out of those 48 cards I will be selecting 4 cards. One already I have selected from ace, as an ace. Now out of 48, 4 cards are to be selected. Children, always remember that addition of these two should always give you the total number of things which is given in the question, and total number of selection should be the sum of these two things. So 48 plus 4 is 52, which are given here. 1 plus 4 is 5. That means 5 selections are to be done. Whenever the word and is coming, that means it should be 4C1 into 48C4. When your word or is coming, then you use plus sign. When and comes, then you use product sign. So this you have to remember. Solve it and get the answer. And after solving, we will get it as, you can pause your video and see the solution. Let's see this question, children. It is given in how many ways can one select a cricket team of 11 from 17 players. That means you are given with 17 players, and out of these 17 we want to select 11 players, in which only 5 players can bowl if each cricket team of 11 must include exactly 4 bowlers. Now out of these 17, 5 people are there who are bowlers and left people are 12. That means here it is given in which only 5 players can bowl if each cricket team of 11 must include exactly 4 bowlers. That means out of these 5, I have to select 4 bowlers. That means it should be 5C4. That means out of 5 bowlers I am selecting 4. And the left players are 12. Total players were 17, 5 were bowlers and rest are 12 which are not bowlers. So out of these 5 I have to select 4 bowlers for the team, and then out of these 12, how many I am going to select, because I need to make team of 11, 4 already I have chosen. Now left players are 11 minus 4, that means 7 players are to be selected. That means 7 players are to be selected from 12 left players. Now children, I told you if you are going to add this, then it should come out to be equal to total number of players. So 12 plus 5 is 17. So here I am having 17 players. 7 plus 4 is 11. That means 11 selection of 11 players are to be done. So I am correct over here, and here I can write it as 4C4 into 12C1. And on solving it by expansion, I will get it as 3960. Let's see this question, children. It is given in how many ways can a student choose a program of 5 courses if 9 courses are available. That means you have 9 courses and 2 specific courses are compulsory. That means out of these 9, 2 are compulsory. Children have to take these 2 subjects, and then we are left with 7 more subjects. Out of these 7, how many they want to choose? Children have to choose 5. So 2 are compulsory. Now left is out of 5, 2 are compulsory, then left courses are 3. That means from 7 they have to choose 3. So I can write it as 7. Out of 7 they want to choose just 3 courses. 2 are compulsory, so we need not to take this 2 courses, specific courses. So we are left with just 7C3. 7 are to be taken and 3 selections are to be done. So solve 7C3 and get the answer. So the answer is, children, one question can arise in your mind that just now I have told you there are total elements are 9. That means total courses available here are 9. So just now I told you the sum should be equal to 9. But where is the sum? 9. So what is this? This is actually into 2 courses are compulsory. So out of these 2 they have to select 2. And 2C2 is just 1. So here this is just 1. That's why I have not used this. You can write this also. But if you have not written it, then also it is correct, because 2C2 is 2. And how 2C2 is 2? This is factorial 2 upon factorial 2 minus 2. Factorial 2. So this is 0, which is 1, and 2 and 2 gone. So this is just 1. Now you see 7 plus 2 is 9 and 5 selections were to be made. So 3 plus 2 is 5. So like this we are done. Calculate 7C3. So 7C3 will be factorial 7 upon factorial 4 into factorial 3. So it will be just 7 into 6 into 5 upon 3 into 2, which is 35. So 35 is your answer. That's it.